Okay, we're looking at problem 55 from lesson 1-4 on page 31. It says solve each equation for x. So I have c times x plus 2 minus 5 equal b times x minus 3. I'm going to use my whiteboard. Here I have it written here. And let me first warn that there are many ways that I can solve for x. So there's not one way to solve for x, and I could get a variation of the answer. But all answers should look similar. The negative signs might be off by a little bit. So let's do it. So the first thing that I'm going to do is I'm going to multiply. I'm going to distribute. So I'm going to get cx plus 2c minus 5, and I get bx plus 3b. So I am now going to move all of my x terms on one side and everything else on the other. So I'm going to subtract cx from both sides. And while I'm doing it, let's go ahead and subtract 3b from both sides. So my cx cancels out over here. And I'm left with 2c minus 3b minus 5, because I can't add any of those terms. They're all unalike. And on this side, my 3b cancels out, and I'm left with bx minus cx. All right, so now my x is still not alone, so I'm going to factor x out over here. So I get 2c minus 3b minus 5 equals x times b minus c. So I'm going to divide now both sides by b. Sorry about that. X is gone, so b minus c, divide both sides by b minus c. And I've run out of space, so I'm going to erase some of this up here. Okay, and I get 2c minus 3b minus 5 all over b minus c equals x, because my b minus c crosses out right here. So one thing I need to make sure I take into consideration is my denominator, because my denominator cannot equal 0. We all know that when a denominator equals 0, when we're dealing with fractions, I get undefined. So let's set this equal to 0. So I have b minus c equals 0, can equal 0. So I'm going to add c to both sides. So basically I can say b cannot equal c. So those terms cannot be equal to each other. So I hope that this helps.